Individuals who specialize in just one field often find it difficult to overcome all challenges. This idea is reminiscent of the limitations we observed in OpenAI's O1 model. Similarly, Tesla's full self-driving FSD system initially employed a domain-specific approach, but when that didn't achieve optimal performance, they transitioned to an end-to-end method. By implementing FSD in an optimized way, it has improved significantly. Hello everyone, this is Era. Have you been making the most of OpenAI's O3 model? Personally, I find it incredibly beneficial. I was so caught up in my DeepSeek project that I didn't have the chance to fully delve into the paper OpenAI published on February 3rd. When I finally reviewed it, I realized that the approach used in DeepSeek was absolutely correct. Moreover, it even supports Tesla's end-to-end full self-driving strategy. The research demonstrates that the full self-driving autonomous approach is indeed the correct one. The paper from OpenAI explains why the O3 model has made significant improvements over the O1 model. As you can observe, for instance, when you select a model like O3, a prompt is generated. This is what we refer to as a chain of thought. You might be asking yourself, who are Elon Musk, Jackson Huang, and Jensen Huang, and why are they relevant? Let me give you an example with something as absurd as Michael Jackson. The importance of this question isn't the point. Instead, the reason I mentioned it is that the detailed process of O3 is revealed through reasoning. Unlike the last time, I didn't utilize the chain of thought method. As I mentioned earlier, within the embedded latent space, the system can continuously refine and improve its performance through repeated iterations. This involves the concept known as chain of thought, where if a user inputs something, the system internally generates a sequence of language, ensuring that the logical flow of thoughts is coherent and well-structured. It helps the LLM understand and connect the context, but this process hasn't been shown yet. What exactly is a semiconductor, and how can it be produced within a year? If we write somewhat ambiguously like this, there are discussions on how to talk about semiconductor fabs. Look at this. These aren't my words, but knowing these terms is essential for understanding the idea. By employing a chain of thought strategy, it creates prompts that facilitate effective and efficient responses. On February 3rd, OpenAI released a comprehensive paper detailing how O3 successfully implements this technique, titled Comparative Programming with Large Reasoning Models. We're talking about how well it has been improved. However, some people might find this paper a bit overwhelming, so I've read it thoroughly to explain it to you. This is about the domain-specific system O1, IOI, which is related to that. It's the Informatics Olympiad. I participated in the Korean Olympiad. I participated in it during middle school and high school. It's an international competition, a programming contest where you solve extremely challenging problems that test your coding skills, similar to difficult math problems. So, we can think of O1 as being specialized for this IOI. Now, when we talk about O3, how is it different? Well, O1 used a domain-specific system, but what does it say about O3? What exactly do we mean by domain-specific strategies or relaxed constraints? You know, it developed well through reinforcement learning and was left to work on its own. Have you ever watched Physical 100, one of Netflix's original series? Hey, so all these incredibly fit and athletic individuals come together and compete, right? So everything runs on a treadmill. There are many really buff people participating. But in the end, like in Season 1 and now in Season 2, the ultimate winner is, this is a bit of a spoiler, but it's Amo-T. Amo-T is the winner of Season 2. And the runner-up is Hong Byom-seok, who was also on Steel Troops. This balance in the lineup is really something. The winners were truly deserving. Was it the snowboarder who won in the first season? So, someone who is proficient in long-distance running and excels in various areas ultimately managed to overcome all the different challenges and tests presented. The reason I'm mentioning this is because Physical 100 featured many incredibly fit individuals. There were bodybuilders and even national athletes like Yang Hak-seon, who excelled in endurance challenges. However, they still faced failures in certain areas. In other words, individuals who were specialized in just one area ultimately could not overcome challenges. This concept is quite similar to what was not quite working in OpenAI's O1 model. Furthermore, when Tesla's full self-driving FSD system was being programmed in various ways and encountered limitations, Elon Musk decided that an end-to-end learning approach was necessary, leading to another significant leap forward. This situation is very much analogous to that. There is a certain resemblance here. So, if we interpret the paper from the perspective of a specialist and someone with extensive knowledge, it offers valuable insights. First, we need to examine the approach used here. They employed the OpenAI O1 method along with an enhanced, fine-tuned version called O1 IOI. This can be considered as an improved iteration. In the O1 model, solutions were generated within the model itself using a chain of thought strategy through reinforcement learning before addressing the problem. This method is actually identical to the one employed in DeepSeek R1. If you review the DeepSeek R1 paper, you'll find that it not only discusses R1 but also introduces R10. So what exactly is this R10 model, you might ask? Essentially, it utilizes reinforcement learning by consistently providing rewards based on the accuracy and structure of its responses, which helps in generating prompts. This method, known as the chain of thought, involves taking multiple incremental steps to gradually enhance accuracy over time. DeepSeek R10 employs the chain of thought methodology to generate incredibly refined outputs, which are then integrated with the base model to eventually form R1. The base model in this context refers to the frontier model from last year, DeepSeek 5.3, which was already leveraging reinforcement learning techniques even in OpenAI's O1 model. Internally, they have been creating these chains of thought, which enable reasoning and logical deduction processes. For example, even when solving a simple math problem, the system continuously generates internal language like 1 plus 1 is 2, so what would 2 times 4 be? Oh, it's 8, and it proceeds in this manner. Just like when I initially wrote down names like Michael Jackson, Jensen Huang, and Jackson Huang randomly, and such prompts were generated, the O1 model used a similar internal method. So we can see that DeepSeek also imitated this approach to some extent, regardless of who did it first. Essentially, they used reinforcement learning to generate a chain of thought. Taking this approach seemed to enhance performance, don't you think? But then, as I mentioned earlier, the O1 IOI is essentially the O1 model with an added focus on the IOI. The International Olympiad in Informatics is specifically tailored to address challenging programming problems that arise in the competition. These include dynamic programming, simulated annealing, various optimization problems, clustering, and other programming methodologies. Efficiently leveraging data structures is crucial for solving these issues within the allotted time. So, the aim is to tackle Olympiad problems by offering hints to facilitate their resolution. This method is known as domain-specific strategies, which are designed to enhance problem solving in particular fields. For instance, strategies like the test time selection strategy are specifically employed to address the public test cases of the International Olympiad in Informatics more effectively. So, we need to include a solution candidate for each problem here, similar to adding 1,000 candy solutions. By doing this, we observed that the O1 IOI has shown improvement compared to the previous O1 model. This is particularly because solving IOI problems comes with time constraints for coding. Removing the time limits and running a full test, the score rose to 2,200 points. The score increased from 1,600 to 2,200, almost a 30% improvement. That's a huge jump. But the next step was tough. The O1 IOI model needed precise feedback and fine-tuning. It used a domain-specific strategy to achieve these results. Remember what I mentioned earlier? Just like in Physical 100, you have these wrestlers or maybe bodybuilders, I can't quite remember exactly, but anyway, these individuals with incredibly strong physiques excel in their specific domains. By training intensively in a highly domain-specific manner, their performance improves significantly, and they become much stronger in their particular field. In the case of O3, the approach is quite different. The O3 model leverages large-scale reinforcement learning extensively. Instead of crafting tailored strategies for specific domains, it autonomously manages its own learning process. For instance, remember how the maximum score for O1 in the IOI was 2,200 points? However, it goes significantly higher than this. This means that with a tremendous amount of weight training, like lifting close to 700 pounds in the 3 major lifts, the O1 model, which is highly specialized for specific tasks, is surpassed by the O3 model, which performs exceptionally well across various domains like CrossFit, running, weightlifting, and even cardio. By extensively training these models, not just focusing on a specific area, but verifying them autonomously in a more general way, and significantly increasing the computation time, the O3 model has demonstrated outstanding performance. This level of achievement is comparable to winning a gold medal at the International Olympiad in Informatics. So, winning a gold medal means that intensive reinforcement learning, when applied rigorously and extensively, is significantly more effective than merely fine-tuning specific parts in a domain-specific manner. Although I read this paper a bit late, the moment I saw it, I realized that DeepSeek R1 was right. And ultimately, Tesla's FSD was also correct. DeepSeek R1 also ultimately employs what is known as the DeepSeek R10 chain of thought through reinforcement learning. And as I mentioned earlier, it utilizes rewards based on accuracy rewards. They demonstrated that by effectively utilizing these two types of rewards, the system could autonomously generate numerous chains of thought and deliver impressive results. However, what advancements did O3 bring to the table, and how did it manage to surpass these already remarkable achievements? The chain of thought method naturally generates solutions autonomously without human intervention. So instead of directing with specific instructions like, check if it's yes or no, and if yes, do this, if no, do that. It operates more like solving problems in the International Olympiad in Informatics, where you are expected to figure out whether to use dynamic programming or divide and conquer on your own. First, try to find the optimal solution, and then choose and verify it on your own. By running reinforcement learning intensively in this manner, the system is able to autonomously discover methods without any human intervention, even for strategies like the test start time. This approach is quite similar to Tesla's end-to-end full self-driving system. Recently, the advancements in self-driving technology have been remarkable, with vehicles autonomously navigating through factory floors. This significant progress was achieved through end-to-end learning, causing quite a stir in the community and on social media. Various tests and training are conducted for overall autonomous driving, aiming to further enhance performance. To achieve improvements, they perform tuning. During this tuning process, if something like a person or a car is detected in front, the system responds accordingly, such as by stopping or navigating a roundabout. Initially, this approach involved direct human feedback, making it domain-specific. However, since this method reached its performance limits, in the end, by optimizing the full self-driving FSD system from end to end, we have achieved significantly improved outcomes. This approach is believed to be a potential step toward the development of artificial superintelligence, ASI, and artificial general intelligence, AGI, as it shows progress in various fields like robotics, autonomous driving, and even LRM. As this approach continues to be strengthened, we are witnessing significant improvements in performance. Ultimately, the O3 method developed by OpenAI can be seen as combining the chain of thought technique used internally by models like DeepSeek R1, which generates prompts by thoroughly ruminating through the chain of thought and integrating it with specific strategies. It requires extensive reinforcement learning and a lot of computing power, so a significant amount of computing is still necessary. For instance, Tesla is working on full self-driving, and OpenAI is about to release O3. To achieve this, they might use NVIDIA's hardware, or have Broadcom build it. Ultimately, these setups are crucial steps towards artificial general intelligence and artificial superintelligence. It's certain that this is the case. DeepSeek's release doesn't make Stargate useless. You don't need to understand all the complex details. For those interested, I'll provide a link for reference. In general, AI trends are moving towards more computationally intensive reinforcement learning and end-to-end methodologies. I will wrap up this paper before bed and share it. Please check out my international channels, and if you are comfortable with English, visit Unreal Tech for more content. I have also translated older videos into English. Additionally, on Instagram, I also share interesting videos, short AI or tech news, and updates from the semiconductor world, so make sure to check them out. This has been Error.